Hello, 7th graders. You need your Unit 7 note packet, a calculator, a pencil, and I think I'm going to challenge your mind today. We are building upon what we did yesterday. This is just another way to see percents in action. The overall learning goal says I can solve real-life percent problems using equations and proportions. The goal today says, I can solve percent problems using equations. That's what we're going to focus on, but we can also solve them using proportions, what we did yesterday. How do you solve for a missing value in a multiplication problem? You might go, Miss Kluver, or I have done this, and it was even back in my elementary days. And just hang with me for a moment, okay? So if you had the problem 3 times something equals 27, what would you do to solve for that something? You would divide by 3. You would use the inverse operation of multiplying by 3, right? So you divide by 3. That would give you 1. 27 divided by 3 is 9. And you know 3 times 9 is 27. How about over here? Something times 6 is 96. How would you figure out what that something is? Well, you would take 96 and divide it by 6. That's going to give me 1. 96 divided by 6, what is that? 16. So how do you solve for a missing value in a multiplication problem? You use the inverse operation, which is division. Now hold on to that. Remember that. Does it work the same for decimals? It being using division to solve for an unknown. Well, absolutely. If it's a multiplication problem, we can absolutely use division to solve for an unknown. So looking here, we can divide both sides by 25/100ths to figure out what our missing value is. So take 10 and 5/10, 10.5, divided by 25/100ths, 0.25. What do you get? 42. So 1/4 of 42 is 10 and a half. And we use division to solve for that. Look over at the next one. 6 equals 5 times something. Could we divide both sides by 5 to figure out what that something is? Absolutely. 6 divided by 5, what do you get? 1 and 2/10. Now check that. 5 times 1.2, what do you get? 6. So yes, using division in a multiplication problem to solve for an unknown gives us the answer that we're looking for. Let's use what we've reviewed in the previous 2 little chunks. What do we have to do with percents before solving? So now we have a multiplication problem and a percent is involved. 75% of some number is 225. This value right here is the part. This value is the percent. We are finding the total. Yesterday we did that and we used the percent equation that was in proportion form, right? We did 75 over 100. We know that the part is 225. Now we're finding the total. So this right here, 7th graders, is another way to see the percent equation. Here it is in proportion form. And you might go, Miss Kluver, you told us that whenever we are finding the total, it's best to use the proportion percent equation here. I agree with you. Here's just another way to see it. So let's use what we've reviewed in those 2 chunks in these notes and do that now. First, since we have a percent involved here, it's a lot easier to work with percents when they're in their equivalent decimal form. So let's back it up, back it up. So 0.75 times something equals 225. We know that multiplying, if we're missing a part, we can use division to help us solve for that unknown. So what are we going to divide both sides by? 0.75. Divide by 0.75, 75/100ths, 3/4. So on your calculator, go 225 divided by 75/100ths, 0.75. What do you get? 300. Now let's check that. Take 300 and multiply it by 0.75. Do you get 225? Yes. We solved working with percents, focusing on, here's yet another equation, a missing value. Look at the next one. You have 5% of 80. Here, 7th graders, you have, like yesterday we did it like this. We have our percent, 5 over 100, of 80. That was the total. You're finding the part. So this is a percent of a number problem. Yesterday we looked at it like this. The day before we looked at it like this. And I said, when it's a percent of a number problem and you're finding the part, it's easier just to change it to a decimal and multiply. But here you are looking at it in both ways. And yet we are talking about it again. So let's go ahead and let's change that percent to a decimal, because I said that would be the most efficient way. So back it up, back it up. So as a decimal, 5% is 0.05 times 80. What does that give us? What do you get? 4. So this value is 4. All right, Ms. Kluver, what are you getting at here? Don't worry, we're building. We're kind of bringing it all together right now. Here are our next 2 examples. Find this chunk in your notes. How do we find a missing percent once we're done solving? Here, we have to solve for the percent. It's the unknown. So let's do that. Let's use what we know about multiplication. We know that to undo or to find a missing part in a multiplication problem, we divide. So I'm going to bring down my equal sign. What am I going to divide both sides by? My goal is to figure out this unknown. I'm going to divide both sides by 45. So this is going to give me 1, and any number times 1 is that number. Divide by 45. So we divided both sides by 45. So if you think about your knowledge of solving equations, we have our percent is equal to 9/45. Now that doesn't mean my answer is 9/45%. No, the percent has a value of 9/45. 9/45 in that fraction form. It's not in percent form right now. So think about how you change a fraction to a percent. You change it to a decimal first and then move it, move it. So go 9 divided by 45. That's going to give you 0.2. Then we need to move it, move it. What percent is equivalent to 9/45? 20. 20% of 45 is that 9. Well, check it out. 0.2 times 45. Is that 9? Yes, it is. And this is actually what we did yesterday, 7th graders. It just looked like this. We were finding the percent. We had the total. We had the part. This, what we did yesterday, is also represented up here like this, where we're using our knowledge of solving one-step multiplication equations. Both of these are the same. You might go, Ms. Kluver, this seems way easier to me working with the proportion. Yes, and remember, we can solve math problems in a lot of different ways. We are using what we already know about multiplication and division and solving one-step equations. Key thing here is when we got this answer of 9/45, that doesn't mean it's 9/45%. That means the percent is equivalent to the value of 9/45. So we changed it into a decimal, we moved it, then we got our percent. Let's look at the next problem. All right, we're finding the percent again. It's multiplication. How am I going to get the 2,500 out of there? I'm going to divide. What am I going to divide both sides by? 2,500. That's going to give me 1. 2,500. And now, here's where you're thinking, okay, my unknown equals 10 over 2,500. Yes, the percent is this value, but the value is in fraction form right now. Let's get it to percent form. How do we go from a fraction to a percent? We start with dividing. So take 10 divided by 2,500. What do you get as a decimal? 0.004. Now let's take the decimal to a percent. How do I do that again? I multiply by 100, so move it, 0.4% or 0.4%. There is the unknown. And again, we did this yesterday. We could set it up in this percent equation proportion form. Listen to the language that I use as I read this equation. 75% of 300 is 225. Now, I could take out a value and I could put in an unknown, and I'll just use a box because that's what we used before. Listen to how I read it again. 75% of what is 225? There are common words that you are hearing. Find the last chunk on the front side of your notes. Here are some key words. What is your unknown number? In our cases of our examples here, the what was represented by a box. Is means equals. So when you see the word is or you're saying is, it's representing equals when it comes to these problems. Of means multiply. When you're taking a value of another value, of means multiply. We talked about that a lot lately, haven't we? And percent, when we're working with percent, this symbol, this word, we're going to change the percent to a decimal. Let's apply now everything we've kind of just put together. And it might seem a little mumble jumbled in your mind, and that's okay. It might seem like this is making it more challenging than it needs to be. No, it's just giving you another way to see a problem. So how do I use an equation in percent problems? We're going to use our keywords up here to help us create an equation. Here's the first example. What is 20% of 250? We know what is our unknown. We know is our equals. 20% is my percent of, when you're taking a number of another number, of means multiplies. Now we can translate it. What is 20% of 250? Here's an example of finding the percent of a number, which is also known as the part. I would say the most efficient way to do that is to change your percent into a decimal, back it up. So it would be 0.20 times 250. That is going to give you your what? So you can use your calculator, type in 0.2 times 250. What do you get? 50. Let's try another one. We have 46% of what number is 23? When you just read it, it's like, what? That's why we have these keywords. And that's why we're going to write in an equation. We could set it up in our proportion too. Absolutely. There's all different kinds of ways. It's called using our number sense skills. 46% of what number? There's my what. It's my unknown. I'm taking a value of another value. This of means what? Multiply. I have my is there. That's equals 23. If you didn't fill in 23 yet in your notes, go ahead and do that. Here's our equation. Let's translate. 46% of what number is 23? Could I use a variable instead of this shape? Absolutely. We're working with a percent here, right? What should we change the percent into? A decimal. We are going to need to solve. This is a multiplication equation. What will get the 46% out of there? If we divide by 46%, but let's get it in its proper decimal form. So back it up. 0.46, 46 hundredths, times something is 23. So now I'm going to divide both sides by 46 hundredths. This is going to give me 1. I'm left with just my something. So take 23 divided by 0.46, which is my 46%. What do you get? 50. So the answer is 50. Here's the last one that I'm going to guide you through, and then you get 2 to try on your own. We have number 3 here. 15 is what percent of 25? Fill in 25. Again, we could set up and plug these in using our proportion. 15 is what percent of 25? I clearly see I am solving for the percent here. So what I would do is I would change this into a decimal, move it, and there would be my percent. This is another way to see the problem, because sometimes it's like, I didn't even understand how this was laid out, Mrs. Kluber. Use these keywords. So we have 15 is what percent? That's my unknown. My unknown is the percent this time. Of 25. I'm taking a number of another number. That means multiply. Let's write our equation out. We have 15 is what percent of 25? Now, what will get the times 25 out of there? If I divide by 25. So I'm going to take both sides and divide it by 25. That's going to leave me with my percent equals, now take 15 25ths right here, change it into a decimal, move it, 15 divided by 25, what do you get? I get 6/10. Now that's the decimal equivalency to 15 25ths. We need to get the percent that's equivalent to that. So we need to move it. What's going to go on that empty hump? 0. So this ends up giving me 60%, right? That is my answer. So I'm going to retrace that here, 60%. These are the two problems that you are going to try on your own. You're going to pause the video, come back and check your answer with mine, but you need to fill in some values. The first one, 32 is 16% of what number? The next one, what percent of 75 is 21? You got this. Go ahead. For the first you try one, I got my value to be 200. And if I check that, if I go 16%, 0.16 times 200, do I get 32? Yes. For the second one, we are finding the percent there. What percent of 175 is 21? So I divided both sides by 175. I'm right here. And I got my unknown is the same as 1200ths, but I needed to change this decimal into the equivalent percent form because that's what it wanted. So now if I take and plug 12% in, and I go 12% is a decimal, 0.12 times 175, I get 21. Okay? And again, could we do all of these problems using what we learned yesterday about the percent proportion? Absolutely. This was our part. This was the total. Okay? This is just another way to see it. And using the keywords is a very helpful strategy.